Hello. Today I'm presenting OrateIQ, an AI-powered public speaking coach that I built using Spec-driven development with 100% AI-generated code. This project demonstrates all four learning objectives, translating design artifacts into formal specifications, using the Spec kit workflow to drive agent implementation, deploying a working containerized application to Azure, and documenting the entire process. Let me start by explaining the problem we're solving. So public speakers today lack objective feedback. They rely on self-assessment, which can be subjective and biased, peer feedback, which is sometimes time-consuming and inconsistent, and online resources, which can be generic. So what's missing? Objective measurement of delivery, including pacing, tone, clarity, actionable, personalized feedback, and progress tracking over time. OrateIQ solves this with AI-powered speech analysis. For this development, I followed the GitHub Spec kit workflow rigorously. Started with the constitution defining the principles, then used the specify command to provide the use cases, system operation contracts, and entity relationships. I used the clarify command to resolve ambiguities like defining the status workflow with granular states for error handling. Then I used the plan command to provide technical details on how I wanted the spec implemented. Finally, the agent implemented everything in task batches, and I reviewed each output against the SOC post conditions. Zero manual coding was done. So here's a look at that traceability in action. I started with design artifacts and translated these into formal use cases and system operation contracts. SOC1 for speech upload defines exact responsibilities and post conditions. This became the contract I gave the agent. As you can see, the generated code, the upload speech controller method, directly implements every responsibility. It validates the file, stores the Azure blob, creates the speech document, publishes the event, and returns confirmation. Every line traces back to a spec requirement. The agent translated this contract into code with about 80 to 90% accuracy on the first try. The application used an event-driven architecture, and the agent generated the entire architecture used by the application from the specification. So a user upload triggers an instant API response, then worker process this asynchronously. The state machine was one of the hardest parts. It took over 5 iterations to get it right. Initially, the spec was missing some granular states, so I refined the spec to include them. For each iteration, I'd run the analyze command, identify gaps, update the spec, and regenerate. One of the challenges with the analyze command I found was it kept finding new issues every time I ran it, making it hard to time box work. But the end result was mostly production grade code. The agent understood the architecture from the sequence diagrams and the SOCs. So for agent implementation, every line of code, all 15,247 lines, were generated by AI using GPT-5. My role was essentially a requirements engineer, prompt engineer, and code reviewer. The agent excelled at boilerplate code, generating 90% usable code on the first try. Overall, the time savings was significant. 40 hours total versus an estimated 120 to 160 hours manually. The key insight: spec quality determines agent output quality, so garbage spec equals garbage code. Rigorous spec equals production code. So the deployment was fully automated with GitHub Actions. There were some challenges here, like getting the environment variable injection right for Azure. It took several iterations, making sure things like MongoDB connection strings, Azure API keys, JOT secrets were properly passed to containers. The agent generated the Docker files and the initial flow, but debugging Azure-specific configuration required some human expertise. The deployed architecture uses container apps for the front-end, back-end, and workers, with MongoDB Atlas for data, Azure Blob Storage for the audio files, and Azure OpenAI, and speech-to-text for AI services. It's also fully reproducible locally using the Docker compose up command. Okay, so next, let me show you the working application. So I'm going to switch over to a browser here and go to the app URL. I'm going to start by registering a new user by clicking the Create One here, entering an email address, password, confirmation password, then create account. Once logged in, I'm presented with the public speaker users dashboard. There's a few options here so they can record a speech. So if I click the record speech button, it'll bring up this modal. I can click start recording. When I do that, you can see there's a timer duration that starts, and there is a field for the title, an optional field for the description. And if I click stop recording, there's an option to preview the recording back as well as upload the recording. I'm going to click this upload speech button here. This will allow me to upload a recording of a speech. I'm going to click choose file. I'm going to select this sample wave file, provided a title. I can also select a mode, which is optional. I'm going to select practice, enter a description, and click the upload button. Once uploaded, the backend stores the audio in blob storage. It creates a MongoDB record and publishes an event for asynchronous processing. Notice that the status updates in real time. First transcribing the speech-to-text worker calls Azure speech-to-text, then analyzing as the analysis worker calculates metrics like filler words and speech rate. Finally, generating feedback as Azure OpenAI produces personalized recommendations. So the AI-generated feedback provides quantitative scores across multiple dimensions, including pacing, tone, clarity, sentiment, complexity. It also provides some comments here describing the speech. It also provides strengths, areas for improvement, recommendations, and also you can see the speech transcripted at the bottom here. So all of this, from transcript to analysis to the AI feedback, was generated by the agent-built backend. So next, I'm going to flip over to my Azure portal. And this is the resource group I used. It's called RG OrateIQ, and I'm calling this the dev environment here. But you can see behind the scenes, the application runs on Azure Container Apps. There's currently 3 containers, one for the front end, one for the back end, the front end for the React UI, the back end for handling the API, and there's a worker one for processing the asynchronous jobs. All these were deployed via GitHub Actions, CI/CD, as you can see over here. And these are the different jobs within that workflow. If I click back to Azure, you can see that there's Azure OpenAI for the feedback generation using GPT-4, and there's also the Azure speech-to-text for the transcription. These external services the workers call during processing. And that's pretty much it. That's the complete flow. So record or upload a speech. Within seconds, you receive a comprehensive AI-powered feedback. All the code was generated by AI agents following the spec-driven development principles. So now I'm going to flip back over to the presentation. So spec-driven design emphasizes continuous refinement. So specs evolve through implementation learnings. One example I had was with the audio file size limit. So initially, the spec said reasonable size, but that's subjective. So the agent would make different assumptions for each iteration. So I had to go back and I researched typical speech file sizes, decided on 50 megabytes as being adequate for about 40 minutes of audio. And I found this to be the power of SDD. So specs aren't static documentation debts. They're executable contracts that evolve alongside the code. So for lessons learned, I found that SDD plus AI is a powerful combination. It prevents vibe coding. The spec acted as a contract, and the SOCs gave me objective validation criteria. The agent was exceptional at boilerplate. It generated TypeScript interfaces from English descriptions with about 90% accuracy. Implementing workers early was also a smart design decision for myself that avoided bottlenecks in the application. But there were some challenges. The agent hallucinated when specs lacked detail. Finding the right level of specificity and not over-specifying but enough to avoid assumptions is still a process I'm learning. The spec kit workflow did have some friction. Sometimes amending the plan would actually delete everything in the plan, so I'd have to undo that. And the analyze command I had mentioned earlier could loop endlessly, finding new issues. Also, I had some difficulties with the UI polishing and the Azure environment variable configuration, which took multiple iterations to get right. But overall, I think I would definitely use this for prototyping in greenfield projects. 70% savings are real as far as time savings. And also, I think it could lower the barrier for domain experts to build software applications on their own, similar to low-code, no-code platforms. There are some concerns that remain, such as junior developers I could see might blindly trust agent code, which could be dangerous. Validation at every gate is critical. Spec drift is a risk. There are also some unknown costs and even broader social concerns like energy demands with usage. But looking ahead, I think specs become even more important. They're executable contracts, not just documentation. Skills like design, communication, troubleshooting, validation, and security will be paramount. So in conclusion, I delivered a functional AI-powered public speaking coach, which with use cases 1 and 2 completes, deployed to Azure with automated CI/CD, with over 15,000 lines of AI-generated code. And the end-to-end processing took under 1 minute, well below the 5-minute target. All 4 learning objectives were achieved. I translated design artifacts into formal specifications, executed the full spec kit workflow from constitution through implementation, delivered a containerized app with 0 manual coding, and documented the entire process comprehensively. A key takeaway for me was spec-driven development plus AI equals systematic engineering, not vibe coding. So humans handle requirements, architecture, and validation. AI provides speed and boilerplate, delivering 70% time savings. Together, we get production quality code with full traceability. Spec quality determines agent output quality. AI needs structure, and spec-driven development provides it. Thank you.